This video is about polar function graphs. This is AP Precalculus topic 3.14. If you appreciate the content, please give it a like. Number 1. Which of the following is the graph of the polar function r equals f of theta, where f of theta is equal to -3 sine 3 theta in the polar coordinate system on the interval from 0 to 2 pi? Let's graph one test value at a time and see how many options we can eliminate. Starting with f at 0. If we plug in 0 for theta, we get -3 sine of 0. The sine of 0 is 0, so we have -3 times 0, which equals 0. So, at 0 radians, we have an r value of 0. We can eliminate any of these options that has anything other than an r value of 0. For option A, here is 0 radians, and the only r value is 0, so A is still in. However, for option B, at 0 radians, we see this r value of 3, not 0, so we can eliminate B. By the way, it does not matter that there's also an r value of 0 at 0 radians. This r value of 0 could come from any angle. Since f of theta is giving us an r value of 0 at 0 radians, and not the r value of 3 that we can plainly see, B is out. Options C and D only have an r value of 0 at 0 radians, so C and D are still in. Next, let's try a value at one of these petals. This is pi over 3. So let's evaluate f at pi over 3 and see if we can eliminate any of the options. So we have -3 sine, and 3 times pi over 3 is 3 pi over 3, which is pi. So we have -3 sine pi. Sine is the y value on the unit circle, and the y value at pi is 0. So the sine of pi is 0. -3 times 0 is 0. We can eliminate any option that has an r value other than 0 at pi over 3. For option A, we see an r value of 3 at pi over 3, not 0. So A is out. Again, it doesn't matter that there's also a 0 here. That could come from any angle. At pi over 3, f is only giving us an r value of 0, not 3, which we plainly see. So A is out. At pi over 3, option C is only giving us a value of 0. So C is still in, and it is the same story on option D. Only 0 here, so we're good. We have narrowed it down to options C or D. Let's pick a value of theta to test that hopefully will eliminate one of these. Let's try f at pi over 2. If I get 3, I know that C is the answer. If I get -3, I'll know that D is the answer. Plugging in pi over 2 for theta gives us -3 times the sine of 3 pi over 2. Sine is the y value on the unit circle, and 3 pi over 2 is right here at the bottom, where the y value is -1. So we have -3 times -1, which gives us +3, not -3. So the answer is C. Number 2, which of the following is the graph of the polar function r equals f of theta, where f of theta is equal to 3 minus 3 cosine theta in the polar coordinate system on the interval from 0 to 2 pi? Let us once again try to narrow it down to the final answer by using test values. Let's let theta equal 0. So then we have 3 minus 3 cosine 0. 0 is right here on the unit circle, at the point 1, 0. Cosine is the x value, so the cosine of 0 is 1. So we have 3 minus 3 times 1, or simply 3 minus 3, which is 0. All four graphs have an r value at 0, so that doesn't really help us narrow it down. Let's try letting theta equal pi over 2. So we have an r value of 3 minus 3 cosine pi over 2. Cosine is the x value on the unit circle, and at pi over 2, the x value is 0. So we have 3 minus 3 times 0. In other words, r is equal to 3. Look at option A. At pi over 2, an r value of 3 would be right here. That does fall on the graph, so A is still in. At option B, pi over 2 does have an r value of 3, so B is still in. Option C. At pi over 2, an r value of 3 is right here. This does not fall on the graph, so option C is out. Similarly, for option D, pi over 2 is right here, and r value of 3 is right here, which does not fall on the graph, so option D is out. We have narrowed it down to either A or B. Let's let theta equal pi. We have 3 minus 3 cosine pi. The cosine of pi is negative 1, so that's 3 minus 3 times negative 1, which is 3 plus 3, so we are talking about an r value of 6. Looking at option A, at pi radians, an r value of 6 would fall right here, which is on the graph, so A is still in. Looking at option B, an r value of 6 does not fall on the graph, so B is out, and the answer is A. Number 3, which of the following is the graph of the polar function r equals f of theta, where f of theta is equal to 1 plus 2 sine theta in the polar coordinate system on the interval from 0 to 2 pi? Let's let theta equal 0. R would equal 1 plus 2 sine 0, and we know that the sine of 0 is 0, so this is 1 plus 2 times 0, which is simply 1. Looking at option A, at 0 radians, an r value of 1 falls right here, which is not on the graph, so option A is out. For option B, an r value of 1 falls right here, which is on the graph. B is still in. For options C and D, an r value of 1 does fall on the graph, so we have only eliminated option A so far. At theta equals pi over 2, we have 1 plus 2 sine pi over 2. The sine of pi over 2 is 1, so we have 1 plus 2 times 1, which is 3. At pi over 2 on option B, an r value of 3 would fall right here, which is not on the graph, so option B is out. An r value of 3 does not fall on the graph for option C either, so C is out, which means D must be the answer, and sure enough, an r value of 3 does fall on the graph. Number 4, which of the following is the graph of the polar function r equals f of theta, where f of theta is equal to 4 cosine 2 theta in the polar coordinate system on the interval from pi to 3 pi over 2? We could probably solve this problem by plotting test values between pi and 3 pi over 2. However, this time I'd like to switch things up and try the strategy where we sketch a rectangular graph of f of theta and use that to choose. I'm noticing the b value of 2, and we have learned that for the cosine function, the period is always 2 pi divided by the b value. So in this case, the period is going to equal 2 pi divided by 2, which is equal to pi. I'm going to go to the fourth mark and put pi for the period. Half of that will be pi over 2. Half of that will be pi over 4. I can use this first mark of pi over 4 to find all of the missing values. I'm going to count by pi over 4. This is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4 is 3 pi over 2, 7 pi over 4, and 8 pi over 4 is 2 pi. The 4 in the front means that the amplitude is 4. So we will have a maximum of 4 and a minimum of -4. 0 is right here in the middle, representing the pole. We have memorized that one period of the cosine function looks like this. And here is a second period. On the rectangular graph, we notice that the interval from pi to 3 pi over 2 has this portion where the r values are positive, from pi to 5 pi over 4, and then there's a portion where the r values are negative, from 5 pi over 4 to 3 pi over 2. Let's see how many options we can eliminate by sketching the part of the graph from pi over 4 to 5 pi over 4. These positive r values should begin at the maximum distance from the pole of 4 and then end at 0. So looking at option A, notice that at pi we begin at a maximum distance of 4, and then as we approach 5 pi over 4, the values go to 0. That is the same thing that we see on option B. At pi, we begin at an r value of 4, and then as we rotate towards 5 pi over 4, the r values approach 0. So both of these graphs so far match this blue portion on the rectangular graph. On the other hand, at pi radians on options C and D, an r value of 4 does not fall on the graph at all. So options C and D are out. Next, let's trace the portion of the graph from 5 pi over 4 to 3 pi over 2. Notice that on this interval the r values are negative. On the polar graphs, from 5 pi over 4 to 3 pi over 2 is from here to here. However, because the r values are negative, the graph will appear in the opposite direction. So we would expect the graph to appear here, which is what we see on option A, and not on option B. So I can already tell that option B is the wrong answer. The answer is going to be A, but I'd like to say a little bit more about it. As theta goes from 5 pi over 4 to 3 pi over 2, we should sketch the graph in this direction. Also notice that we begin at the pole and move away from the pole to a maximum distance of 4. So here we go. We begin at 0, right at the pole, and we move away from the pole to a maximum distance of 4. So everything I just described matches perfectly what we see in option A. Example 5. Which of the following is the graph of the polar function r equals f of theta, where f of theta is equal to theta in the polar coordinate system on the interval from 0 to 3 pi over 2? We should be able to answer this one intuitively. The r value is simply equal to the angle. Therefore, as the angle increases, the r value increases. So we are looking for something that spirals out like this. All of the answer choices feature some type of a spiral. So we just need to find the one that starts at 0 and ends at 3 pi over 2. Option A spirals from pi to 5 pi over 2. Nope. Option B does spiral from 0 to 3 pi over 2. That's exactly what we are looking for, so the answer is probably B. Option C involves 0 and 3 pi over 2, but it is spiraling in the wrong direction. Instead of starting at an r value of 0 when theta equals 0, it starts at an r value of 4 point something at theta equals 0, and then gets smaller as we rotate from 0 to 3 pi over 2 instead of bigger as it should. So C is not the answer, and D is not even close. So the answer is B. You could also solve number 5 using a test value. You know how pi is approximately 3.14? In fact, let's say that pi is approximately 3. In that case, pi over 2 is approximately 1.5. Since the r value and the angle are equal, the r value at pi over 2 radians should be approximately 1.5. And that is exactly what we see on option B. At pi over 2 radians, the r value is approximately 1.5. On the other hand, for option A, 1.5 does not fall on the curve. Nor does it fall on the curve for option C or option D. Number 6. Which of the following is the graph of the polar function r equals f of theta, where f of theta is equal to 6 sine 4 theta in the polar coordinate system on the interval from 0 to 2 pi? Let's use the strategy where we sketch a rectangular graph and use that to choose. I'm noticing this b value of 4, and we know that for the sine function, the period is always 2 pi divided by the b value. So the period will be 2 pi divided by 4. So that's going to be pi over 2. The period always ends at the 4th mark. So I'm going to put a pi over 2 right here because that's the period. And then half of that would be pi over 4. And half of that would be pi over 8. Now I can count by pi over 8 to find more values of theta. This is 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8. 6 pi over 8 is 3 pi over 4, 7 pi over 8, and 8 pi over 8, which is pi. That should be enough. The 6 in the front means an amplitude of 6, so we will have a maximum of 6 and a minimum of -6. The midline, 0, is the pole. One period of the sine function looks like this, and here's a second period for you. Focus on the interval from 0 to pi over 4. Notice that we begin at the pole. We start at 0, we move away to a distance of 6, and then we return to the pole at 0. So this should be one petal of the flower. So we are looking for a graph that has a single petal on the interval from 0 to pi over 4. And these are positive r values, so the petal should be right in this sector. Option A does not appear to have a nice petal right between 0 and pi over 4. So it's looking like option A is not going to be the answer. Option B is not looking good either. We have sort of half of a petal here, so that's no good. Option C is looking really good. See how we have one petal nicely from 0 to pi over 4. We start at 0 and we go out to a distance of 6 and then return to 0. That's exactly what we saw on the rectangular graph. Option D is not looking good. We have two halves of a petal, but not a single petal between 0 and pi over 2. On the interval from pi over 4 to pi over 2, we should see another petal on the flower as we begin at the pole, move away from the pole to a distance of 6, and then return to the pole. Since the r values are negative, we should expect to see this petal in the opposite direction from these angles. Pi over 4 to pi over 2 is right here, but again, because of the negative r values, we would expect to see a loop in the opposite direction from here to here, and that is exactly what we see. From pi over 2 to 3 pi over 4, we expect to see another loop as the r values go from 0 to 6 back to 0. Because of the positive r values, we expect to see a loop in the same direction as the angles, and that is exactly what we see. This is more than enough to be confident that the answer is C. You could also solve this problem using a test value. For example, if you let theta equal pi over 8, then 4 times pi over 8 is 4 pi over 8, and you get r equals 6 times the sine of 4 pi over 8. In other words, r is equal to 6 sine pi over 2. The sine of pi over 2 is 1. So when theta is equal to pi over 8, the r value should equal 6. Pi over 4 is right here. So pi over 8 should be halfway. At pi over 8, none of these graphs have an r value of 6, except option C. So that's another way we could find that the answer is C. Number 7. Which of the following is the graph of the polar function r equals f of theta, where f of theta is equal to 6 cosine squared theta in the polar coordinate system on the interval from 0 to 2 pi? Let's try letting theta equal 0. At theta equals 0, r is equal to cosine squared 0. The cosine of 0 is 1, so r is equal to 6 times 1 squared. At 0 radians, r should equal 6. Looking at option A, at 0 radians, r equals 6 is not on the graph, so A is out. Look at option B. At 0 radians, r equals 6 is on the graph, so B might be the answer. Option C. At 0 radians, r equals 6 is not on the graph. C is out. Option D. At 0 radians, r equals 6 is not on the graph, so D is out. So the only option that has an r value of 6 at 0 radians is option B. So the answer is B. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.